मैसेज फॉर अस अवल अल्लाह नूर उपाया कुदरत के सब बंदे एक नूर ते सब जग उपजया कौन भले को मंदे. In the beginning Allah created the light. From that light He has created all mortal beings. From the one light the entire universe welled up. So who is good and who is bad? Unit 5 Part 3 Properties of Colloidal Solutions. Properties of colloidal solution. The first property is the colligative properties of colloidal solution. The colloidal particle being bigger aggregates the number of particles in a colloidal solution is comparatively small as compared to true solution has the value of colligative property are of small order as compared to values shown by the true solution at the same concentrations. The second property of colloidal solution is the Tyndall effect, very important. Now what is Tyndall effect? When a beam of light is passed through a colloidal solution, the path of beam is illuminated when viewed at right angle to the passage of light. This effect was first observed by Faraday and later studied in detail by Tyndall and is termed as Tyndall effect. Now, what is Tyndall effect? We have here an experimental setup. There is a colloidal solution, there is a source of light, there is a microscope, and eye to observe the scattered light. Now, from a source of light, light is emitted, and these light particles strike the colloidal particle. The colloidal particles scatter these light particles, and this process continues. And these scattered particles are observed by the eye and the colloidal particle becomes visible due to this reason and the path of light is illuminated and this illumination of path of light when it is passed through colloidal solution is called Tyndall effect. Now we are seeing this again and again. Colloidal particles are scattering the light in all directions. uh, Cause of Tyndall effect. The Tyndall effect is due to the fact that colloidal particles scatter light in all directions. Now, conditions for Tyndall effect. The diameter of the dispersed particle is not much smaller than the wavelength of light used. The second condition, the refractive indices of dispersed phase and dispersion medium differ greatly in magnitude. The next property of colloidal solution is the Brownian movement. The continuous zigzag motion of colloidal particles is known as Brownian movement. This motion is independent of the nature of the colloid. It depends on the size of particle and viscosity of solution. Smaller the size, the lesser the viscosity, faster is the motion. Let's see the animation. Colloidal particle moving on zigzag path. This is known as Brownian movement. Cause of Brownian movement. The Brownian movement is due to the bombardment by the molecules of dispersion medium on colloidal particle. It is the unbalanced bombardment by the molecule of dispersion medium on colloidal particle which is the cause of Brownian movement. Note, the Brownian movement has a steering effect which does not permit the particle to settle and thus is responsible for the stability of source. Therefore, Brownian movement result in the stability of colloidal solutions. Color. And the color of colloidal solution depend on the wavelength of light scattered by the dispersed particles. The wavelength of light further depend on the size and nature of the particle. The color of colloidal solution also changes with the manner in which the observer receives the light. Now, for example, if we have the impact of size, finest gold soul is red in color. As the size of particle increases, we are increasing the size of particle, its color also changes. It appears purple and then blue and finally golden with the increase of size of particles. A mixture of milk and water appear blue when viewed by the reflected light and red when viewed by the transmitted light. Now both have the impact size of particle, colloidal particle, as well as in the manner in which we receive the light in our eye. Charge on colloidal particle. Colloidal particle also carries an electrical charge, either positive or negative. The nature of the charge is same on all the particles in a given colloidal solution. A list of some common souls with the nature of charge on their particle is shown in the next slide. We have given some positive souls and we have given some negative souls. Examples are given. The charge on soul particle is due to one or more reasons. First reason is due to electron capture by soul particles during electrodispersion of metals. Second reason is due to the preferential adsorption of ions from solution. And third is due to formation of electrical double layer. Note the preferential adsorption of ion by the is the most accepted reason. Preferential adsorption, second one is preferential adsorption of ion is the most accepted reason. When two or more ions are present in the dispersion medium, the preferential adsorption of the ion common to colloidal particle usually takes place. For example, when we add AgNO3 solution to potassium iodide. We are adding AgNO3 to Ki. What will happen? AgI will be precipitated and AgI will attract negative ion, I negative ions from the dispersion medium, and it will form a negative soul. If we do the reverse, if we add Ki solution, potassium iodide solution to AgNO3, then what will happen again? Reaction will be same. AgI will be precipitated, and now AgI will attract the Ag positive ions from dispersion medium, which are present in excess in dispersion medium, and in this case we will get a positive soul. Okay. Now, similar is the case when FeCl3 acid to excess in hot water, and however when ferric chloride is added to NaOH. Different kind of souls are formed. One is from the positive soul, and fourth one formed with negative soul. Electrical double layer, or electrokinetic potential, or zeta potential. Having acquired a positive or negative charge by the colloidal particle, this layer attract counter ion from the dispersion medium, forming a double layer as shown below. In first case we had a negative soul, AgI attracted I negative, and this will attract K positive from the dispersion medium, and there will form two layers. One is the fixed layer, that is of the colloidal particle, and other is the diffused layer, that is mobile layer, that is of the dispersion medium ions. In the same way in the next case as well. The combination of the two layers of opposite charge around the colloidal particles is called Helmholtz electrical double layer. Since separation of charge is a sheet of potential, the charges of opposite signs on the fixed and diffuse part of the double layer result in a difference in potential between these layers. This potential difference between the fixed layer and the diffused layer of opposite charges is called electrical potential or zeta potential. Electrophoresis. What is electrophoresis? Important concept. When electric potential is applied across two platinum electrode dipping in a colloidal solution, the colloidal particle move toward one or other electrode. This movement of colloidal particle under an electric field, applied electric field potential, is called electrophoresis. Positive charged particle move toward the cathode while the negatively charged particle move toward anode. Let's have the animation. Electric experimental setup. We have a colloidal solution in YouTube. Negative charge colloidal particle are shown. When the electric potential is applied, the negative soul particles will colloidal particle will move positively cathode. And when electrophoresis, that is the movement of particle, is prevented by some suitable means, it is observed that dispersion medium begins to move in an electrical field. This phenomena is termed as electroosmosis. And note number 2, the existence of charge on colloidal particle is conferred by the electrophoresis experiment. Now, seventh property is coagulation or precipitation. The stability of lyophilic salts is due to the presence of charge on colloidal particles. If somehow the charge is removed, the colloidal particle will come nearer to each other to form aggregates or coagulate and settle down under force of gravity. This process of settling of colloidal particles is called coagulation or precipitation of the soul. Coagulation can be brought about the following methods: by electrophoresis, by mixing two oppositely charged souls, and by boiling, and by persistent dialysis, and by adding electrolyte. A negative ion causes precipitation of positive charge soul and vice versa. The ion responsible for neutralization of charge on the particle is called coagulating ion. Hardy-Squeeze rule, it has been observed that generally the greater the valence of flocculating ion added, the greater is its power to cause precipitation. This is known as Hardy-Squeeze rules. It means the coagulating power is directly proportional to the valence of the added ion. In the coagulation of negative soul, the flocculating power of the is the order Al3 positive maximum, then Ba2 positive, and then Na positive. As charge is decreasing, the coagulating power is also decreasing. Similar is the next case, coagulation of positive soul, the flocculating power is given below, and coagulating value, the minimum concentration of an electrolyte in millimoles per liter required to cause precipitation of a sol in 2 hours is called coagulating value. Smaller the quantity needed, the higher will be the coagulating power of an ion. Now, coagulation of lyophilic soil, the two factors which are responsible for the stability of lyophilic soils are, first one is charge and the second one is the solvation of colloidal particles. When two factors are removed, the lyophilic soil can be coagulated. This is done by adding an electrolyte and by adding a suitable solvent. When solvents such as alcohol, acetone are added to lyophilic soil, the dehydration of dispersed phase occurs. Under this condition, a small quantity of electrolyte can bring about coagulation. The second one is the protection of colloid. Lyophilic soils are more stable than lyophobic soil due to the fact that lyophilic colloid are extensively solvated. When a lyophilic colloidal solution is added to the lyophobic soil, the lyophilic particle form a layer around the lyophobic particle and thus protect the latter from electrolytes. Lyophilic colloid used for this purpose are called protective chloride. The situation may be compared with a minister and his security guards. Suppose minister are lyophobic and security guards are the lyophilic. The minister is protected by security guards. In the same way, lyophobic colloid is protected by lyophilic colloid. Therefore, lyophilic colloid protect the lyophobic colloids. Thank you for watching this video. Be home, be safe.